Scooby's helping unpacking over here. He likes bubble wrap. So I just got this box of flywheels came in the mail here. So bubble wrap does not protect flywheels, but it makes Scooby happy. Right, Scooby? Did you get that last one? You look tired. I'll show him the new piece over there. He's getting mad. So anyway, they wrapped them in this this here, which didn't do anything. Holes in bags. When you have all your parts just lay in the box and you put a couple pieces of bubble wrap on top, it doesn't protect the parts any. He did double layer the box here, so the box, it got here in one piece. See, the box don't have any holes in it. That's a plus. Okay, now for the bad parts. So, looks like this flywheel here got some damage on it. And my guess this is caught on a chain tension, the primary. They put too long of a bolt and it hit on the side of the flywheel. And then it kind of had a grinding situation on it. And more than likely it knocked the crank way out of true. And he lost the main bearing in his case here. It screwed up the case at one point. And you can see how this has been walking around in the case. See how loose it's been? See all that shining stuff right there? That means it was loose in the case. See over here where it's ground? That's the part that was tight. That's how it was made originally. So this was loose. What happens when you tighten the bolt up on the flywheel, it bends the thing in half, knocks it out of true, and it wobbles like this. And that wobbling action eats up the main bearing like this, and loosens it up in the case and chews it all up. It all destroys everything. Cases, crank, all that stuff. So this shaft here, the other thing I see is it was bottomed out here on the taper, on the shoulder right here. So that's a common problem on these old iron head bikes. And what happens is when you torque this thing down, there's a light on the subject, would be nice, there we go. When you tighten these things down, they bottom out on the shoulder right here. Your nut over here is tight, but your shaft is loose. So what happens is, it'll start working back and forth like this, and it eats up the taper and eats up the keyway. Now this one here, it didn't look like it got to that point. You can see how the keyway is a little bit worn, but not too bad. And the taper still looks good. So if he was driving harder, he would have knocked the damn shaft right out of this motor. But you can see how it's all polished here. You can see how it's been walking around in there though. So that's more issues. So to correct that problem, you've got to cut the shoulder off, or you got to cut the flywheel away so that when you tighten this down, it tightens up on the taper and not that shoulder. The taper's what keeps it tight, not the shoulder. So I do both. You know what mood I'm in. But you don't want to cut so much off of the shoulder. So a lot of times I just cut the flywheel. Now obviously your timing mark on this one's getting hard to read, so that needs to be re-gouged into it. So I need to deburr this edge a little bit, a little rough. It looks like crap, but doesn't really hurt anything. What does hurt things is when the taper like that gets clogged. Now all of this metal that was going to go into the motor, which would have been this stuff right here, which is cast iron, it was going through the whole motor and chewing it up, so it chewed up the washers a little bit. Nothing really bad. You can also see how it was eating up on the cage was eating away on the flywheel here too. So that means that one of these cages should be pretty well chewed up. Oh yeah, probably that one right there didn't. This did not pass the shipping test because everything was bouncing around inside this box. So yeah, that kind of chewed that up. We have a few extra nicks now on the back on the flywheels, I've noticed already. Alright, so now I need some new cages. That one's bad. Anyway, what happens is the material here in the cage acts like a lapping arbor. The hard metal, which is your cast iron, digs into here, and then it chews up the flywheel over here when it rotates around the circle. See how this side here is smooth? Just because it had a race against it. Ah, broke another one. This one took a hit too. So you see how both of these two sides are smooth? This one here is smooth, and this one here, see, it's a little rough. You can also feel the sharpness on the edge. But when the flywheel gets out of true like that, the rod is going to walk one way or the other. And it usually goes against the left flywheel, but in this case, this is the right one, isn't it? Yeah. In this case, it walked to the right, which is the opposite way it normally goes. So anyway, all that material got in here and it was eating away on this thing. As it rotated around, it was lapping away on the damn thing, which makes more material. Vicious circle. The crank pin, you see all this blackness on the pin, that's not good. That's a lot of heat and wear. Well, it's not pitted that I see yet. Of course, I'm not cleaning it very well right now. So it's not pitted, but it has a lot of wear in it. So it looks like it could be reused probably, but it's not round or true anymore. I don't like reusing crank pins because it's the first thing that fails with a crank pin, and boy, I save money on that part. Just like the bearings, I like to don't reuse those either. The main shaft, you can get away with that. Now the rod is a replacement set of rods. That's what the replacement means. Now this side here is smooth. This side is smooth. So this set of rods is not the set that came out of the motor that was damaged. That did all this other damage over here on this side and this side. This set of rods is not the one that did it. The reason they replaced the rods is probably because this whole side, this rod was all chewed up. It's probably missing quite a bit of it on here originally. You can see how the motor had a lot of heat on the front cylinder versus the rear cylinder. You can see how it was thrusting real bad though. See how the piston, the rod's pushed against the piston here? That's not good. A little bit on that side too. So that was pushed on the left side of the bike. This is the left, this is the right. So this crank was pushing pretty hard to the left, and the pistons were trying to hold it. So basically you had your piston, say this here was the piston in here. Normally the rod is just supposed to make the motor go around and not have any drag side to side. When the cranks are out of whack and they start twisting on you, they put a side load over here and it shoves everything over this way, and the piston's still trying to hold it square. And that's what bends rods and breaks rods. And causes all the thrusting on the sides over here. And this one here you can also see it's got some corrosion. Yeah, I don't think I've weared against that surface. It looks good. Definitely loose, so. Alright, so one plastic bag almost made it. See, we get to diagnose what all the problems were. So even though you'd lie and tell me what you did or didn't do, I can tell by what's going on, by the parts when I'm looking at them. That's one reason why I like to clean the parts, because I know what the motor is when I'm looking at the parts. When you're cleaning stuff, you can see all the damage and what was done. Okay, this shaft here looks pretty nice. See, this is normal wear here. See how this is a darker wear over here, and you got more sliding going on. This is abnormal. This is more abusive wear, higher RPM. So this has a lot more wear in it than this pin here. So plus this turns it has less load on the connecting rod. Over here is where the bushing is on the cam cover. Now this will control your oil pressure. If this is bad, you have no oil pressure. Because the oil pressure has to build up to go through the rod set, and it has to build up right in this bushing right here. If this hole is loose or bad, it dumps all the oil out of the motor. It goes in the bottom of the cam cover instead of going back into the rod where it belongs. Alright, so all of this stuff looks okay here. Looks like that took a big hit. Yeah, that got dropped on something in the shipping. Now, I don't use these locks in here. They go over here like this. I've seen too many motors where these nuts here were loose and the locks are still in the motor. So these things get loose, they go over the top of the locks and they keep right on rotating back and forth. Because when this shaft like this one over here is walking around like this, the nut gets loose. And like I said, this lock doesn't do a damn thing. So I don't put them in. Waste of time. Alright, well that's how we're diagnosed it for now. So you can see what you're looking at. So now I guess we do to rebuild it.